What is gravity?
I have no idea. Okay, next question.
And by the way, this is called gravity.
You're totally blowing my mind right now.
That's what I do. I'm Neil deGrasse Tyson, bitch.
What's up, guys? John the Morgile here, checking in for a new Flat Earth video for you. Hope you do enjoy it. So today we're going to talk about gravity. And gravity is one of the most important theoretical fictions involved with the standard/ball Earth paradigm. Whenever discussing the static plane Earth paradigm with those new to the topic, gravity will inevitably come up in the conversation, as it is indeed a powerful piece of the mind control program, which by and large hinges on the round Earth deception. Gravity is a phantom of the spinning ball Earth theory, which is only necessary if you grant the assumption, at least for argument's sake, that we live on a spinning ball in the first place. When you realize that the world is in fact a stationary plane, then the fact that dense objects fall and less dense objects or fluids rise is a result of the natural order of things, which is ultimately governed by the static electric charge of the Earth, it would appear.
Why is it that sometimes, out in the ocean, a boat could float, and then unfortunately sometimes it would sink? In order for a boat to float, all it has to do is displace its weight or push away its weight in water. This clay object I fashioned into the shape of a ball. This one I kind of made into the shape of a boat. It too weighs 50 grams. So, both objects are made out of clay. Both weigh 50 grams, but only one of these two is actually going to float. And you probably guess which one's going to float or sink. Let's start with the clay ball. Let's place it in this overflow tank, this displacement tank. And, not surprisingly, it sank like a rock. And a bunch of water is coming out on this end. How much water comes out? Well, if we wait long enough for all the water to drip out that would drip out, it would come out to about 30 milliliters on our graduated beaker. That is equal to the volume of this clay ball, that is, how much space it takes up. But what we're really interested in today is not something sinking, but more about why is something floating. So let me fish this ball out of the water. And this time, let's float the clay boat. Now to do this precisely, we have to... And look at this. It's floating, and it's pushing out a volume of water. Now this time, the amount of water that comes out on this side is not going to be 30 milliliters. It should be 50 milliliters at least.
The tendency for higher density objects or fluids to find their place of rest at a lower elevation to less dense media simply needs no further explanation when examined with the understanding that the world is not a spinning ball. Only when one assumes this ridiculous and absurd theory that we must invent theoretical apologies using some of the wildest mental acrobatics ever witnessed to come up with things like gravity. The fact that what goes up must come down is, under most normal circumstances, the fact of reality, which both sides of this discussion agree on. The mechanics of this rather simple system are what is under criticism and what is ultimately debunked in terms of the theory of gravity. Let's assume the Earth is a spinning ball hurling around the sun as they claim. Then you would need some force to keep a person or oceans and lakes from flying off of the ball, especially as you approach closer to the equator, due to the alleged centrifugal forces which would necessarily increase relative to one's proximity to the equator. The fact of the matter is, there is no discernible difference between one's experience right smack on the equator or directly on one of the poles, when you're allegedly standing in two completely different environments when it comes to sheer velocity. And again, at the equator you're allegedly zipping along the circumference of the Earth at over 1,000 miles an hour, well faster than the speed of sound, and an observer at the pole supposedly not spinning at all. Certainly no 1,000 miles an hour, but about half the speed as the hour hand on a clock. The fact that gravity is sufficient to keep all of the world's oceans and lakes and butterflies stuck to the world with perfect balance, both at the Arctic regions and at the equator, in a fashion which is perfectly balanced with nature at all points equally, is a very impressive feat indeed for a force which is claimed to be inanimate or consistent from the equator to the poles. In other words, gravity allegedly applies itself evenly to all locations of the so-called globe Earth, according to the theory, completely irrespective of the world's spin at the given latitude. And yet we have this huge disparity between velocities, allegedly, at the equator versus the poles. If you mean to tell me you wouldn't notice the difference between going around a curved surface at 1,000 miles an hour and standing still, then I got a bridge I'd love to sell you. Let's also keep in mind that we have to combine the alleged spin of the Earth with the orbital velocities, and that's a whole nother video in and of itself, but it is important to remember that we're not talking about a system with no acceleration, because that is what we should sense and detect and measure and document is acceleration. And so for morning to night we have an acceleration that is vast, going from 66,000 miles an hour in one direction to 66,000 miles an hour in the opposite direction every 12 hours, switching direction, switching velocity 180 degrees. Huge amount of acceleration just in terms of the orbital velocity of the Earth plus the alleged axial rotation. And we also must combine that with the galactic frame of reference and everything, but again, that is another video. Speaking just specifically of the problems with gravity, the spinning Earth, again, it varies from latitude to latitude, yet the experience does not. It is claimed that things weigh slightly less at the equator due to the centrifugal force, but it is a negligible amount. I would need to measure that for myself before I would call it a fact, because the amount is so minuscule. I'm sure that it is within the margin of error of any of the equipment used to measure it in the past, if it ever has even been measured. I would submit that it's possible that nobody has ever traveled actually to the equator and weighed an object and then mailed the same object to the North Pole and had someone else weigh it. What goes up must come down is completely contrary to the spinning ball Earth due to the manner in which centrifugal forces operate. And even though it is indeed contrary to the entire layout of the system, spinning around on a ball, things somehow fall to the Earth. The theory of gravity is thus crafted to apologize for this fact, completely disagreeing with their idea of reality, and somehow or another it has become exclusive proof of the spinning ball Earth. So people like Neil deGrasse Tyson will drop their microphone on the ground to prove that the Earth is a spinning ball, or to prove gravity, or whatever he's trying to prove. But the fact of the matter is, he's demonstrating what goes up must come down. That is a fact that everybody agrees on. Only in the spinning ball Earth theory must one do mental acrobatics and gymnastics to arrive at a comfortable position where you can explain why things fall. And of course, the theory of gravity is just so far out there. When you look at it, they claim that the fabric of infinite space is not only physical space, but non-physical hypothetical time, space-time. It's one thing, which is, in my opinion, just patently absurd. And just because Einstein thunk something up does not make it a fact. Space and time simply cannot be meshed together into a fabric. That's ridiculous. That's absurd. That is theoretical mental gymnastics, which is only necessary if you first assume the Earth is a spinning ball flying around in outer space. Now, furthermore, when large, very large, and only very large objects disrupt the fabric of space-time, there is essentially a surface tension created, and space and time push back against the disruption in it from the giant massive ball. And so that's why things stick to the side of the spinning ball, is because space-time is displaced by the giant ball Earth and is thus pushing back down upon it. That's what they claim gravity is. It's frankly ridiculous. It's one of the most ridiculous things you'll ever contemplate, actually. And yet, the fact that objects fall, high-dense objects fall, is somehow equated to exclusive proof that the Earth is a spinning ball, of course. Of course. Because everything comes back to proving the Earth is a spinning ball, because that's what they taught us when we were gullible toddlers, and that's what we're going to continue to think until the day that we die, even when presented with evidence to the contrary, just all over the place. There's never-ending mountains of evidence to prove that the Earth is stationary just as it seems and is a plane just as it appears, right? Gravity, again, it's only necessary in the event that the world is a spinning ball, and when you prove the fact that there is no curvature to the Earth, and it is not a spinning ball, it is in fact stationary, and it is a plane, when you prove that, the theoretical necessity for gravity goes right out the window, so it's not even theoretically necessary anymore. We don't need to explain why objects fall to the ground. Objects fall to the ground based on their relative density. Density and buoyancy is definitely a thing that everybody can agree on, and the crux of density and buoyancy falls down to one thing. What causes relatively high density objects to fall? And the fact is, the Earth holds a static electric charge that's measurable. Static electric charge is always of an attracting force, and it will attract higher density objects at a greater rate or at a greater ratio than less density objects or fluids. And there you go. You have the natural order of things based on density and buoyancy and governed by the static electric charge of the Earth. So until recently, they didn't even claim to have physical evidence for gravity. That's when they came up with evidence, invented evidence from, I think, 1.2 billion years ago, 1.2 billion light years away. And they claim to have captured this evidence by LiGo'd. Yes, LiGo'd. It's an interferometer device, the largest in the world, I believe. There's two of them. And basically they picked up what are essentially vibrations on a chart. So as time went forward, activity on the chart went up. And that is their proof from gravity from 1.2 billion years ago. Yep, LiGo'd.
We have detected gravitational waves. They were detected by LiGo'd, the Laser Interferometer Gravitational Wave Observatory. LiGo'd is the most precise measuring device ever built. Let me start with what we saw. So on September 14th, 2015, Anna recorded a signal, and the signal had a very specific characteristic. The characteristic of, as time went forward, the frequency went up. And now it took us months of careful checking, rechecking, analysis, looking at every piece of data to make sure that what we saw was not something that wasn't a gravitational wave, but in fact it was a gravitational wave. And we've convinced ourselves. That's
the case, and we're here to announce that today.
By the way, this is not a Hollywood production that I'm going to show you. It is actually a real computer simulation, 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 a real computer simulation.
Talk about the gravitational waves. You didn't see any gravitational waves there. What you saw was actually the black holes. Now let me look at this from the gravitational wave perspective. So you're going to see again a computer simulation. This is a real simulation. So you're going to see again a computer simulation. This is a real simulation. A computer simulation. This is a real simulation. A computer simulation. This is a real simulation. A computer simulation. This is a real simulation.
Let me start with what we saw. So on September 14th, 2015, the two LIGO observatories in Hanford, Washington, and Livingston, Louisiana, recorded a signal nearly at the same time, nearly simultaneously, and the signal had a very specific characteristic. The characteristic of, as time went forward, the frequency went up.
The concept of infinite space also goes right out the window when you realize flat Earth, and so too does the concept for gravity and space-time and all the rest, dark matter. In fact, the same can be said about nuclear hypotheses, which in my opinion entails what are essentially little solar systems at the atomic level. And while there is definitely use for the science that has been developed around observation in things like the periodic table of the elements and atomic weight and things like that. That is very helpful and very useful when visualizing things. But on the other hand, I just don't believe there are little particles called atoms and photons and electrons. I think that's a bunch of pseudoscience. At any rate, gravity is not scalable, which means while we should see evidence for gravity on the micro scale, or on the scale that we can sort of tangibly work with here in reality, much like magnetism is scalable. So it doesn't matter how large you make a magnetic system, it's going to work essentially the same way whether you make it in the nano scale or in a scale larger than life, right? Magnetism works scalably. Unfortunately, gravity is not scalable, and so when you take, let's say, a high dense object, take a bowling ball, and you take some powdery substance of a low density like flour, you would expect to see evidence of gravity with the bowling ball acting upon the flour, baker's flour or whatever, and yet you don't see that happen, because gravity, well, frankly, it doesn't exist. There is no mass attracting mass. That's what they claim essentially that gravity is space-time is warped, and this high density, high mass objects attract relatively smaller objects, and you don't see that on the micro level because it simply doesn't exist. The only experiment historically where they say that it exists is the Cavendish experiment, which is just an absolute fiasco.
Henry Cavendish, even though he was part of the rich dukes of Devonshire, that family, and incredibly rich, he went to Cambridge to study natural sciences, or natural philosophy as it's called. But he had a very curious condition in that he could hardly talk to anybody. So when it came to his Viva exam after 3 years of study, he fled Cambridge rather than sit in front of the examiners because he was petrified of them. But he was one of the most brilliant scientists of that 18th century in both chemistry and physics. For chemistry, he's noted because he analysed gases in the air. He discovered there was hydrogen, which is a huge component of the universe. He called it inflammable air. So he put some acids in a container, dropped some metal like zinc into hydrochloric acid, and got the gas to come off. And then to show it was inflammable, you could set light to it, he breathed it in and blew it into a candle. Now, do not do this at home, because it blew up and took all the hairs off his face. He invented the idea of electric potential before everybody else, and used to set electric currents through his body to work out the voltage is proportional to current, and he measured the current by the degree of agony he felt with the electrical current. This is not the normal sort of person.
Oh, Frederick, are you all right?
Yes. Would you excuse me for 1 minute, dear?
Oh, of course, Doctor.
Igor? May I speak to you for a moment?
Of course.
Sit down, won't you?
Thank you.
No, up here.
Oh, thank you.
Now, that brain that you gave me, was it Hans Delbrück's?
No.
Ah, good. Would you mind telling me whose brain I did put in?
And you won't be angry?
I will not be angry.
Abby someone.
Abby someone. Abby who?
Abby Normal.
Abby Normal.
I'm almost sure that was the name.
Are you saying that I put an abnormal brain into a 7.5-foot long, 54-inch wide gorilla! Is that what you're telling me? Quick, get it up!
What? 3 syllables, yes?
I wonder who that could be at this time.
Current by the degree of agony he felt with the electrical current. This is not the normal sort of person. He couldn't talk to most people. He couldn't talk to women at all. His housekeeper would get a recipe for something or other and he'd say, no, lamb tonight, leg of lamb, and leave a note for her. He wouldn't say it, he'd write it. He would dine in the evening with his friends and he would talk to them, but if he didn't know somebody, and you wanted to ask him a question, apparently you had to go to the Royal Society and he would be in the room and you'd address the room this question about physics and you postulate, and if he felt in the mood he would reply to the room. He was a very strange man, and yet he's absolutely wonderful. He invented hydrogen. People went up in hydrogen balloons and could see the world from through that perspective. He did most of the experiments quietly on his own, keeping his notebooks, and it was only after his death and a persuasive campaign by Clerk Maxwell, the famous Maxwell of Maxwell's equations from Cambridge University, that he actually got the notebooks from the estate of the Dukes of Devonshire and discovered after the event that Cavendish had discovered the unit of capacitance, discovered dielectric constants, he discovered Dalton's law of partial pressures, he discovered or written about Coulomb's law, all before these guys had done it and just left it unpublished in his notebooks. Towards the end of his life, he did a crucial experiment, which is represented by these lead balls. He lived in Clapham Common, which is nowadays a very poor part of London, but there it was quite fashionable. And he built his own place. His library he built somewhere else because he didn't want anybody borrowing his books from his house. Otherwise, he would have to ask the book back and he didn't want to talk to them. So his library was 4 miles away. At the back of it, he had a big garden shed, which might seem like the size of my house. And in it, he had 2 lead balls, like this, suspended from the ceiling. Only this is not to scale. This is, lead balls. Now, the real problem is that he wanted to measure the attraction between 2 objects due to gravity. In other words, there's a gravitational attraction between you and me, or between me and this lead ball. So he had to be a long way away to look at the experiment, otherwise he'd interfere with it. So he had an aperture, a place where he looked through, and he put a telescope out there, and he stood outside in all weathers, and he was in his 60s doing this, staring through the window to take his measurements over a year. There's another set of lead balls inside there. This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated. And then right in the middle there's a bit of glass, there's a mirror which should be suspended from a torsion wire. So you'd set it up like this in his shed, and you put it like that, and this lead ball would attract that lead ball, and this lead ball would attract this one. And so it would be pushed a little bit this way and twist the wire, and that would be pushed a little bit that way, and the wire would twist, and as the wire twists, the mirror, which is dangling in there, would twist a little bit, and light which comes in would be reflected off at a slightly different angle, and all he had to do was measure the angle. He then had to move it the other way round. Oh, he didn't move this bit, he moved the lead balls round so that you had an equal and opposite effect on the other side. So instead of you'd have that configuration, he had this is a very complicated technical thing for the time. 18th century we're talking about, and he put that way round, and then it was pushed the other way, and you could then see the displacement. Moreover, you could measure the period of oscillation of this, and from that get all the properties of the wire, the torsional constant. And that enabled him to measure big G, the gravitational constant, to an accuracy of 1%, and nobody improved on that for 100 years. He didn't describe it as that. He described it as though he was weighing the Earth. He was calculating the mass of the Earth, so that when you're attracted to the Earth through gravity, it's the product of the mass of the Earth, this big gravitational constant, divided by r squared, the radius of the Earth squared. which we normally know as acceleration due to gravity. And that quantity is essentially big G, and he measured it. And nobody could do a clever experiment. So he's a father of physics, experimental physics, some of the ideas of theoretical physics, and a lot of chemistry.
So isn't it funny that the only experimental evidence that we have for gravity goes back hundreds of years to Cavendish, and then there's a lapse in any sort of experimental evidence for gravity up until the year 2015, when LiGo'd discovers 1.2 billion year old evidence for gravity waves. I mean, it is a bit convenient that gravity was very much in the realm of theory right up until the point when flat earthers were pointing this out, and then magically and mystically we get evidence for gravity. So isn't it just a bit convenient that gravity remained in the realm of theory, gravitational waves more specifically, but gravity in general remained in the realm of theory until just after flat earthers started pointing this out to the population, and in fact debunking the heliocentric model and making the rather obvious and true assertion that gravity doesn't exist. It's again a figment of the imagination. It is a phantom of the globe earth theory. And again, this is not to argue what goes up must come down. Yes, even flat earthers agree that if you drop a brick on your foot, it's going to hurt. Or if I jump out of a window, I'm going to fall and hit the ground. Yes, that is all true indeed. Again, the point that is in contention here, the thing that we're arguing here, is what exactly causes it, right? So with all that caveat out of the way, it wasn't until very, very recently, and again, this is right after flat earth proponents start pointing all this stuff out, these problems with the ball earth in general, that's when science, or science with a capital S, scientism, steps forward with their so-called proof of gravity or gravity waves. So I'm going to read a couple of articles, or read through a couple of articles. I don't know if I'll read through the whole thing, but I may, because there's just a lot of gold in here, and I will interject as necessary. The first article is going to be from spaceplace.nasa.gov, and the second article is going to be from www.newsscientist.com. I will put links in the description box for you guys below in case you're interested in reading. Okay, so this first one here, I really kind of enjoyed reading this, so I may read the whole thing. It is a bit lengthy, but again, this is not published by flat earthers, not in the slightest. This is written by standard globe earth believing bona fide lientists who are pointing out that LiGo'd lies. Well, I don't know if I'd go so far as to say that, but LiGo'd definitely stretches the truth, living up to their name, and honestly, I couldn't have said a lot of this stuff better myself, no way, and so I'll just let the scientists say it. Again, these are their own guys. One of the boys is writing this stuff against LiGo'd. So let's go ahead to it. And again, this is newsscientist.com. The article's called Exclusive: Grave Doubts Over LiGo'd's Discovery of Gravitational Waves. And this is a bit dated. Don't you just love how they never date an article? Here we go. Yes, they do. Okay, so October 31st, 2018. So this was, wow, Halloween, All Hallows Eve. Okay, so, again, this article's written by Michael Brooks. October 31st, 2018, newscientist.com. Alright, so the news, we had finally found ripples in space-time reverberated around the world in 2015. Now it seems they might have been an illusion. Let me just stop it right here. So you mean to tell me that the real computer simulations might have been an illusion?
By the way, this is not a Hollywood production that I'm going to show you. It is actually a real computer simulation.
You mean to tell me that the ripples in space-time might not have been detected? Because again, you guys, I mean, come on, space-time. I mean, think about that just for a second. Space-time. You've got physical, tangible, measurable space. This is a thing. This is an object. Objects exist in space. It is of a physical nature. It is of substance. It damn sure ain't ethereal. This is corporeal. This is tangible space and meshed together with time, a construct of the mind in order to organize events along a chain. So this would be like verb stuff, right? Okay, so time is definitely not a tangible thing that you can touch and pick up. There is no weight of time. It is certainly altogether different than space, right? So right out the gate here, you guys, I'm terribly sorry that just because Einstein thunk of a thing called space-time doesn't mean that it is a thing, okay? We certainly do have space, and we certainly do have time, but I'm sorry, kids, space-time just ain't a thing, okay? The idea of space-time is tantamount to claiming that you can weigh the dream of a fart, right? So how much does the dream of your fart weigh? And scientists at NASA would have an exact answer for that. Okay? That's about the same realm that space-time is in as far as I'm concerned. So I got off a bit into the weeds right here in the first sentence of this article, so I'll just take it from the top again, because it is just a lovely, lovely opening to an article coming from mainstream scientists who just love NASA. They wear NASA underwear. They've got NASA baseball caps. These guys love them some NASA and some space-time, okay? The news we had finally found ripples in space-time reverberated around the world in 2015. Now, it seems they might have been an illusion. Okay. There was never much doubt that we would observe gravitational waves sooner or later. This rhythmic squeezing and stretching of space and time is a natural consequence of one of science's most well-established theories, Einstein's general relativity. So, when we built a machine capable of observing the waves, it seemed that it would only be a matter of time before a detection. And, you know, I would have to sort of agree with this sentiment. I mean, assuming the ball Earth sort of universe where we have balls spinning around in space, somehow magically held together in their orbits by some invisible force, a gravité, naivete, I would say, you know, eventually you'd think you would be able to find some experimental evidence for it. So I agree with that first paragraph. I mean, eventually you should find evidence for such a thing, right? It should be, well, frankly, everywhere. Much like magnetism, you can find experimental and tangible evidence for magnetism, even though you can't see magnetism, right? We do know that it is there, and there are different ways that you can prove it is a thing in reality, right? Not so much for gravity, but anyway, continuing on with the article. In point of fact, it took 2 days. The Laser Interferometer Gravitational Wave Observatory collaboration, better known as LiGo'd, I gotta tell you, the guy that writes the acronyms for NASA definitely earned his $100 million on that one, I gotta tell you, right? I mean, it costs a lot of money to come up with these acronyms, and it's hard to be NASA, so that guy deserves a bonus, okay? The Gravitational Wave Observatory collaboration, better known as LiGo'd, switched on its upgraded detectors on 12 September 2015. Within 48 hours, it had made its first detection. It took a few months before the researchers were confident enough in the signal to announce a discovery. Headlines round the world soon heralded one of the greatest scientific breakthroughs of the past century. In 2017, a Nobel Prize followed, and 5 other waves have since been spotted. Or have they? That's the question asked by a group of physicists who do not have their heads shoved entirely up their bungholes. No, I made that part up. A group of physicists who have done their own analysis of the data. Quoting these physicists, quote, "We believe that LiGo'd has failed to make a convincing case for the detection of any gravitational wave event," end quote, said Andrew Jackson, the group's spokesperson. According to them, the breakthrough was nothing of the sort. It was all an illusion. The big news of that first sighting broke on 11 February 2016. In a press conference, senior members of the collaboration announced that their detectors had picked up the signature of gravitational waves emitted as a pair of distant black holes spun into one another. Wow. Distant black holes, and mind you, black holes are also very much in the realm of theory, certainly do not exist in reality, knowing that flat Earth is the truth, but even from the standard infinite space paradigm, black holes are very much in the realm of theory. Nobody has ever gone up to a black hole and verified that it is there, right? So, 2 hypothetical things spun around and hit each other. I mean, this is really about as tangible as the dream of a fart. I mean, it is almost a perfect analogy there. So, spun into one another. The misgivings of Jackson's group, based on the Niels Bohr Institute in Copenhagen, Denmark, began with this press conference. The researchers were surprised at the confident language with which the discovery was proclaimed and described to inspect things more closely. With which the discovery was proclaimed and decided to inspect things more closely. So perhaps these guys were actually doing some science over there. They weren't just jumping on bandwagons and agreeing with things that the guy said who's head of the multi-billion-dollar Lie Factory. I gotta tell you, it is very easy to just jump on the bandwagon with the guy heading up the multi-billion-dollar Lie Factory, because I'll tell you what, scientists love to get paid, and so, you know, if the billion-dollar Lie Factory is saying something and the guy who's heading it is saying something, why would you argue with him? Why would you question him? Why would you science? Scientists, I mean, come on, what are you guys thinking out there sciencing like some scientists? Yeah, right. So anyway, and I would say that really is the big news here, is that scientists were actually sciencing. But anyway, I digress. We'll get back into the article. So these dreams of the farts spun into one another. The misgivings of Jackson's group, based on the Niels Bohr Institute in Copenhagen, Denmark, began with this press conference. The researchers were surprised at the confident language with which the discovery was proclaimed, and decided to inspect things more closely. Well, sorry, I read that double. What the hey? Their claims are not vexatious. And I went ahead and looked up vexatious, because that is not a word I'm familiar with, so you learn something new every day. For your information, all y'all phonics elite out there. Vexatious means causing or tending to cause annoyance, frustration, or worry. Right. Well, I guess that makes sense. I know what vex means, right? So their claims are not vexatious, nor do they come from ill-informed troublemakers. Although the researchers don't work on gravitational waves, they have expertise in signal analysis and experience in working with large data sets such as the cosmic microwave background radiation, the afterglow of the Big Bang theory that is spread in a fine pattern across the sky. Okay. Quote, "These guys are credible scientists," says Duncan Brown at Syracuse University in New York, a gravitational wave expert who recently left the LiGo'd collaboration. Wow, so he's actually got some backbone there, doesn't he? And yeah, I would say these guys are credible scientists because they're actually sciencing. They are actually questioning things that are put before them instead of just believing them, gobbling them up, and regurgitating them as fact. Well, the multi-billion-dollar Lie Factory said it was true, so, it must be true. No, not these guys. So, moving right along, gravitational waves are triggered by the collisions of massive objects, such as black holes, theoretically, or neutron stars, theoretically. They travel for billions of years, hypothetically, according to the ball earth theory. And I promise I'll stop with the caveats, okay? So just please forgive me. I tend to go a bit buck wild with the caveats. But of course, I think at this point it should go without saying that I do not subscribe to light years or neutron stars or black holes or any of that. So just consider this a blanket caveat statement for the rest of my reading of this article. Although I promise you I will probably still pepper some in. So it says here, they travel for billions of years, alternately squeezing and stretching the space-time in their path, spreading out in all directions. They get weaker as they go, but they can be detected on Earth with a sufficiently sensitive instrument. Wow, really? The LiGo'd collaboration built 2 such instruments. So not 1, but 2 multi-billion-dollar Lie Factories. Don't you guys just love footing the bill for that? These 2 Lie Factories, the Hanford detector in Washington State and the Livingston detector in Louisiana. A 3rd independent instrument called Virgo, located near Pisa, Italy, joined the others in 2017. These interferometers shoot lasers down 2 long tunnels, then collect them back in such a way that the pulses should arrive at the same time. Passing gravitational waves will distort space-time, making one tunnel longer than the other, and throwing off the synchronization. By the time the waves wash over Earth, the so-called gravitational waves wash over Earth, they are extremely weak, and the sort of change in tunnel length we expect is equivalent to about 1,000th of the diameter of a proton. Okay, let me say that again. 1,000th of the diameter of a proton. Now, I really hate to get off in the weeds again, but you guys, I'm here to tell you, at least in my humble opinion, there's no such thing as protons. There's no such thing as atoms, there's no such thing as nucleuses, neutrons, electrons, none of it. It's all fantasy. It's all a model in order to explain things in such a way as that we can understand them. So I do believe that there is definitely validity to things like the periodic table of the elements and atomic weight and chemistry and things like that. Absolutely. There is definitely a science there. What I'm saying is there's no such thing as little particles called atoms, and certainly not photons. That would be little particles that are racing away from a light source at light speed and hitting your eyeball. You would think that would hurt. Okay, we're talking about little physical objects, very tiny subatomic particles flying at the speed of light hitting you. I'm here to tell you, as far as I'm concerned, that crap does not exist. Okay? For a myriad of reasons, but we won't get into that at the moment. But of course, the measurement that they're talking about here is so small. Mind you, an atom has never been imaged. That's how small they are. Well, I would say they're so small they don't actually exist. But then again, a proton is even smaller than an atom. We're talking a subatomic particle, smaller than the smallest unit of matter as far as mainstream science is concerned. So not only smaller, but 1/1000th the width of a proton is what the Lie factory is looking for when they take their measurements here. Okay? Continue with the article. That is far smaller than the disturbances that come from background seismic tremors and even the natural thermal vibrations of the detector hardware. Noise is a huge problem in gravitational wave detections. I would say another huge problem in gravitational wave detections is gravitational waves don't exist, but hey, I am a bit biased, so continuing on. Hence why there are detectors in different places. We know that gravitational waves travel at the speed of light. Do we now? We know that something that we don't really know even exists, which doesn't exist. We know how fast they travel. We know they travel at the speed of light for sure, absolutely. So any signal is only legitimate if it appears in all the detectors at the right time interval. Subtract that common signal, and what is left is residual noise unique to each detector that, at any moment, because its seismic vibrations and so on constantly vary. Okay. This is LiGo's main ploy for extracting a gravitational wave signal from the noise. But when Jackson and his team looked at the data from the first detection, their doubts grew. At first, Jackson printed out graphs of the two raw signals and held them to a window, one on top of the other. He thought there was some correlation between the two. He and his team later got a hold of the underlying data at the LiGo. The underlying data the LiGo researchers had published and did a calculation. They checked and checked again, but still they found that the residual noise in the Hanford and Livingston detectors had characteristics in common. We came to a conclusion that was very disturbing, says Jackson. They didn't separate signal from noise. Sounds like some 101 stuff, but hey, what do I know? And you know, these people like Jackson, I'm telling you, they are just one step away from flat earthers. I'm here to tell you that somebody such as this Jackson guy who's actually questioning the data from LiGo, or questioning the claims made by these guys, were he to actually give flat earth a fair shake, really have the information in front of him that I'm well aware of, and really dig into it, and spend some time on it, and really actually scrutinize the heliocentric ball Earth infinite space theory. Somebody like him, I can tell, could potentially become a flat Earth proponent, but the problem is these very smart, brilliant scientists are just so entrenched into the models that they've grown up with, it is physically or nearly impossible for them to think outside of the confines of what we've been told is possible, right? So literally the globe Earth is a prison for our minds in more than one way. It is a literal prison for our pioneering spirit, and it is a prison for our minds because it makes it impossible for people to go along certain lines of inquiry, right? That's a big, huge problem, but I'll go ahead and pray right now that this, did he say his name was Andrew Jackson? I think that's what he said, but this Jackson guy, I pray to the Most High, creator of all, that he moves wisdom and revelation into the path of Jackson, and that he may delve down the path of truth and find the truth about the static plane Earth, and share it with all his friends. He'll probably lose his job and his prestige, but at least we will have somebody on our team with all the acronyms after his name that the trolls can laugh at and call a stupid moron, right? But there you go. Pray that to the Most High, everybody, for Mr. Jackson. And pray that he's okay through it, because I'll tell you, it can be quite the tribulation on one's personal life and financial life and everything, but I do pray for revelation for Jackson and his team, and really everybody. Anyway, enough of that. The Danish team wrote up their research and posted it online. After receiving no response from the LiGo'd collaboration, they submitted it to the Journal of Cosmology and Astroparticle Physics. The journal's editor, Vyacheslav Mukhanov of the Ludwig Maximilian University in Munich, Germany, is a world-renowned cosmologist. The editorial and advisory boards include top physicists such as Martin Rees from the University of Cambridge, Joanna Dunkley at the University of Oxford, and Andre Lindy of Stanford University in Cali. Mukhanov sent the paper for review by suitably qualified experts. Reviewers' identities are routinely kept secret so they can comment freely on manuscripts, but these were people with a high reputation, says Mukhanov. Nobody was able to point out a concrete mistake in the Danish analysis. He says, quote, "There is no mistake," end quote. A storm in a teacup still? General relativity is one of our most well-verified theories, after all, so there is every reason to think its prediction of gravitational waves is correct. And, that is just a loaded sentence right there. General relativity is one of our most well-verified theories. Not been proven, not been demonstrated. It is a theory. General relativity is a theory, okay, after all. And he said, this article says, there's every reason to think its prediction of gravitational waves is correct. Well, that is, of course, unless you realize the entire foundation for everything Einstein is kaput. If the Earth isn't a spinning ball, which it is not, the Earth is flat and stationary, quite the contrary to a spinning ball, then everything regarding to general or special relativity goes right out the window. But I digress. I'm straying away from the article here. I'll continue on. It continues, we know LiGo should be sensitive enough to detect them. The instruments are finding the waves at exactly the right rate predicted by theory. So why worry about this noise? Seek and ye shall find. Very wise words there. There's a simple answer to that question about why worrying about the noise.
1, 2, 3, 4, noise, noise, noise. Smoking weed, doing coke, drinking beers, rolling fatties, smoking blunts. Who smokes the blunts? We smoke the blunts, rolling blunts and smoking.
Physicists have made mistakes before. Nuh-uh, I don't believe it. Cite your sources. I'm kidding. Yeah, physicists have made mistakes before. Mistakes that have been exposed only by paying close attention to experimental noise.
Noise, smoking weed, doing coke, drinking beers. Pack her ass, my good man. Time to kick back, drink some beers, and smoke some weed.
See, embarrassing noises. And there's a whole sub-article there. I will fly out just in case time permitting, but I doubt it. The first step to resolving the gravitational wave dispute is to ask how LiGo's researchers know what to look for. And that was the big question I had backing away from the article again. I was always wondering, if you've never seen a gravitational wave before, how do you know what to look for? Like let's say you sent somebody out on a hunt for snipes. Go out and find me a bunch of snipes. I want a dozen snipes. But you don't know what a snipe is. Nobody's ever seen a snipe. There's no books on snipes, nothing on snipes. There's no information on snipes. Well, how the hell could you ever find 12 snipes and bring them back? Do you understand? So this was always a point of contention for me personally, is like, what the hell is LIGO actually looking for, and how would they know a gravitational wave even if they found one, even if they did exist, right? Anyway, straying off topic. The first step to resolving the gravitational wave dispute is to ask how LIGO's researchers know what to look for. The way they excavate a signal from noise is to calculate what a signal should look like, then subtract it from the detected data. If the result looks like pure residual noise, they mark it as a detection. Working out what a signal should look like involves solving Einstein's equations of general relativity, which tell us how gravitational forces deform space-time theory, or at least it would if we could do the maths. So again, just loaded up sentences here, just loaded with malarkey. So again, Einstein's theory of space-time is going to be deformed by gravitational forces to a certain degree, but if space-time doesn't exist and gravity doesn't exist, then what the hell exactly are these guys looking for? And I guarantee you, none of them ever stopped to think and ask themselves this question. Anyways, so carrying on with the article, which tells us how gravitational forces deform space-time, or at least it would if we could do the maths. Quote, "We are unable to solve Einstein's equations exactly for the case of two black holes merging," end quote, says Neil Cornish at Montana State University, a senior figure among LIGO's data analysts. Instead, the analysts use several methods to approximate the signals they expect to see. The signals they expect to see. So, I think I found a snipe. Let me grab one or two of them and see if we're in the right direction, because I mean, if I can find one or two snipes and bring them back, and it turns out they're not snipes, I'm glad I didn't go and get 12 of them, right? Okay, so the first, known as the numerical method, involves cutting up space-time theory into chunks. Cutting up space-time into chunks. Wow. And can you do me a favor and cut me a blaze of fire into chunks and weigh that for me, please? Thank you. And while you're at it, if you could measure the width and breadth of my dream that I had last night, or no, I'm sorry, the dream that my fart had last night, if you could measure the width and breadth of that dream, I would really appreciate it. No, not the whole dream, the room that I was in the dream of the fart. I need to know the dimensions of that room. Please, thank y'all. Of course, you guys, I'm being silly here, but anyways, I'll continue on here more seriously. Instead of solving the equations for a continuous blob of space, you solve them for a limited number of pieces. This is easier, but still requires huge computing power, meaning it can't be done for every possible source of gravitational waves. A more generic approach, known as the analytic method, uses an approximation of Einstein's equations to produce templates for gravitational wave signals that would be created by various sources, such as black holes, theories with different masses. These take a fraction of a second to compute, but aren't accurate enough to model the final merger of the two black holes. This endgame is modeled in an add-on calculation in which researchers tweak the parameters to fit the results of the initial analytic solution. Let me read that last bit again. The endgame is modeled in an add-on calculation in which researchers tweak the parameters to fit the results of the initial analytic solution. Wow. This sounds more and more like pseudoscience to me, but what do I know? I'm just a guy out here getting paid $250,000 a year to come up with anagrams and trying to find a dozen snipes. Anyways, we've got a picture here. I'll read the little caption. To spy gravitational waves, LIGO's detectors need a quiet environment. Yeah, so they build it, as Bob mentioned on Globebusters a couple weeks ago, they build it right by fault lines and by highways, and yeah, please, quiet, be quiet everybody, we don't want any gnats farting over here. Anyways, So, this use of pre-calculated templates is a problem, Cornish concedes. With a template search, you can only ever find what you're looking for, right? Agreed. Quote, what's more, there are some templates, such as those representing the waves created by certain types of supernovae explosions, that LIGO researchers can't create. Yeah, that would be a problem, wouldn't it? That's why Cornish prefers the third method, which he helped to develop. It involves building a model from what he calls wavelets. So just theories on top of theories on top of theories, ain't it? Okay, he calls these models wavelets. These are like tiny parts of a wave signal that can be assembled in various ways. You vary the number and shape of the parts until you find a combination that removes the signal from the noise. Because wavelet analysis makes no assumptions about what created the gravitational wave, it can make the most profound discoveries. The wavelets, quote, allow us to detect the unknown unknowns, end quote, says Cornish. So it allows them to detect the snipes. Right. Even though we still don't know what the heck a snipe is. The downside is that they tell us nothing about the physical attributes of the detected source. For that, we have to compare the constructed signal against the templates or the numerical analysis. I know this is getting wildly confusing, you guys, but bear with me. I promise there's a payoff here. I hope there is. The challenge with all three methods is that accurately removing the signal from the data requires you to know when to stop. In other words, you have to understand what the residual noise should look like. That is exceedingly tricky. You can forget running the detector in the absence of gravitational waves to get a background reading. The noise changes so much that there is no reliable background. Instead, LIGO relies on characterizing the noise in the detectors so they know what it should look like at any given time. A lot of what we do is modeling and studying the noise, says Cornish. And you know, honestly, you guys, I wish I could apply my snipes analogy to this paragraph here, but it's just so damn complex and convoluted. I probably could, but I just don't want to spend the time on it. I think you kind of get what they're saying here, but it is just a load of malarkey, my man. Just a load of malarkey. Anyway, quote, the paper on the first detection used a data plot that was more illustrative than precise. Jackson is suspicious of LIGO's noise analysis. Go Jackson. Isn't that what scientists are supposed to do? Be suspicious of things and double-check things. Yay. Gold star for Mr. Jackson. And I'm sorry, Miss Jackson. Woo! I am for real. Anyway, one of the problems is that there is no independent check on the collaboration's results. That wasn't so with the other standout physics discovery of recent years, the Higgs boson. The particle's existence was confirmed by analyzing multiple, well-controlled particle collisions in two different detectors at CERN near Geneva, Switzerland. Both detector teams kept their results from each other until the analysis was complete. Or did they? I question everything. That's a whole other can of worms. We're not going to go into Higgs boson and CERN just yet, maybe in another video. But at any rate, by contrast, LIGO must work with single, uncontrollable, unrepeatable events. Although there are three detectors, they work almost as one instrument. And despite there being four data analysis teams, they cannot work entirely separately because part of the detection process involves checking that all the instruments saw the signal. It creates a situation in which each positive observation is an uncheckable conclusion. Outsiders have to trust that LIGO is doing its job properly. Let me just read that last sentence again. Outsiders have to trust that LIGO is doing its job properly. And when it comes to theoretical science guys, you know, these guys who are getting just millions and millions of dollars to do, well, fuck all as far as I'm concerned, we have to trust that they're doing their job properly. And by the way, they named their multi-billion-dollar lie factory LiGo'd. So at least they're honest about one thing, right? Yeah. Purely illustrative. And there are legitimate questions about that trust. New Scientist has learned, and New Scientist is this website that we're reading from here, that we're sourcing here. New Scientist has learned, for instance, that the collaboration decided to publish data plots that were not derived from actual analysis. The paper on the first detection in physical review letters used a data plot that was more illustrative than precise, says Cornish. Some of the results presented in that paper were not found using analysis algorithms, but were done by eyeball? What? Say what? I mean, come on, you guys. I don't even think when you go down to the local dispensary and buy a quarter-ounce of pot, they do that by eyeball. And that's just grows on trees, and it's legal in many states. Brown, part of the LiGo'd collaboration at the time, explains this is an attempt to provide a visual aid. It was hand-tuned for pedagogical purposes. He says he regrets that the figure wasn't labeled to point this out. And in case you were wondering, pedagogical, it means relating to teaching, which, embarrassingly enough, never heard that word before today, so wow, we really are increasing our useless vocabulary today, aren't we, you guys? Pedagogical. Ask me to remember that word tomorrow, and I will probably not. So it was hand-tuned for teaching purposes. He says he regrets that the figure wasn't labeled to point this out. So it was labeled as if it was fact, but it was more along the lines of just to maybe make a point or to teach, right? That's the way I'm reading it. Maybe I'm wrong, but hey, pedagogical. There you have it. So this presentation of hand-tuned and eyeball data in a peer-reviewed scientific report like this is certainly unusual, and I would call it just downright fraud, but hey, who am I? I'm still trying to find snipes out here. New Scientist asked the editor who handled the paper, Robert Garisto, whether he was aware that the published data plots weren't derived directly from LiGo'd's data, but were pedagogical and done by eyeball, and whether the journal generally accepts illustrative figures. Garisto declined to comment. So, just a quick point here, you guys. Everybody who has all the kerfuffle about peer-reviewed this and peer-reviewed that, well, you know, LiGo'd, the multi-billion-dollar lie factory, does things by eye sometimes, just wild guesses sometimes, and sometimes they put things in there just for pedagogical purposes. Didn't you know? Okay. There was also questionable shortcuts in the data LiGo'd released for public use. The collaboration approximated the subtraction of the Livingston signal from the Hanford one, leaving correlations in the data. The very correlations Jackson noticed. There is now a note on the data release webpage stating that the publicly available waveform, quote, was not tuned to precisely remove the signal. Wow, well, isn't that just something? Jeez, what are these guys doing, man? Hey, can we have their budget and explore south? I'd really love to know what's out there, you guys. Give us LiGo'd's budget and a couple of years, man. I guarantee you we'll come up with some just fascinating stuff that'll be actually tangibly worth a damn to humanity in the future. Promise. Guarantee it. Anyways, back to the article. Whatever the shortcomings of the reporting and the data release, Cornish insists that the actual analysis was done with processing tools that took years to develop and significant computing power to implement, and it worked perfectly. However, anyone outside the collaboration has to take his word for that. That's problematic. And you know what? It even says so in the article. Quote, it's problematic. There's not enough data to do the analysis independently, says Jackson. It looks like they're being open without being open at all. Reminds you of anyone? I'm not going to say any names, but NASA. I'll go ahead and read that last bit again. Again, this is Andrew Jackson, quote, It looks like they're being open without being open at all. Wow. Brown agrees that there's a problem. Quote, LIGO has taken great strides and are moving towards open data and reproducible science, he says, but I don't think they're quite there yet. So if they're not doing reproducible science, then what the crap are they doing out there in their multi-billion-dollar lie factory? I would love to know, and so would many other taxpayers, I'm very sure. Do you want uppies, baby? Come on, hold on. Come on, I'll put you uppies. Come on. 1, 2, alright, there you go. Don't steal my seat. Don't steal my seat. That's my seat. Seat thief. You're such a little seat thief, Buddhas. Good God. Okay. The Danish group's independent checks, published in 3 peer-reviewed papers, found that there was little evidence for the presence of gravitational waves in the September 2015 signal. On a scale from certain at 1 to definitely not there at 0, Jackson says the analysis puts the probability of the first detection being from an event involving black holes with the properties claimed by LIGO at 0.000004. That is roughly the same as the odds that your eventual cause of death will be a comet or asteroid strike directly hitting you, or, as Jackson puts it, pretty damn consistent with 0. The probability of the signal being due to a merger of any sort of black holes is not huge either. Jackson and his colleagues calculate it as 0.008. But this is proof of gravity, isn't it, globetards? Oh, sure it is. And monkeys might fly out of my butt. Alright. Simultaneous signal. There is other evidence to suggest that at least one of the later detections came from a gravitational wave. Which, of course, gravitational waves do not exist, but we're going along with this article, because at least these guys have one thing going for them. They don't have their heads completely up their butt so far that the little lump in their throat is their nose. Right? So at least they don't have that. On 17th of August 2017, right before the Great American Eclipse, no less, the orbiting Fermi telescope saw a burst of electromagnetic radiation at the same time as the LIGO and Virgo detectors picked up a signal. Analysis of all the evidence suggests that both signals came from the brutal collision of 2 neutron stars. And again, notice how it says that the evidence suggests that both signals came from the brutal collision of 2 neutron stars. But I'm here to tell you guys, as a flat Earth proponent, knowing what we do know, there's no such thing as neutron stars. Stars are just lights in the sky. So if they do collide, maybe they collide. I don't know. I don't think anybody's ever witnessed stars collide with the naked eye. As far as I know, the stars in the night sky have never moved a smidgen relative to one another. So I guess we're going to have to take their word on this too. Anyway, brutal collision of 2 neutron stars. The double whammy makes LIGO's detection seem unequivocal. Even here, though, the Danish group is dissenting. Thank God for the Danish group. They point out that the collaboration initially registered the event as a false alarm because it coincided with what is known as a glitch. And I guess that's the technical term for it. A glitch. The detectors are plagued by these short, inexplicable bursts of noise, sometimes several every hour. They seem to be something to do with the hardware with which the interferometers are built. The suspension wires and seismic isolation devices, Cornish says that LIGO analysts eventually succeeded in removing the glitch and revealing the signal, but Jackson and his collaborators are again unconvinced by the methods used and the fact that there is no way to check them. And isn't that the thing about science? It's supposed to be repeatable and checkable. We're not just supposed to have to take some multi-billion-dollar lie factory's word for things. That's the thing about science. Whatever it is these guys are doing at LIGO, it sure as hell ain't science, I'm sorry to say. Continuing with the article, what are we to make of all this? Tons of money for LiGo'd, that's for sure. Nothing, apparently. The Danish analysis is just wrong, insists Cornish. Quote, there were very basic mistakes. Those mistakes boil down to decisions about how best to analyze the raw data. And see another subsection, how to catch a wave. Anyway, not everyone agrees that the Danish choices were wrong. Quote, I think their paper is a good one, and it's a shame that some of the LiGo'd team have been so churlish in response. By the way, churlish means rude. So they've been pretty rude about people actually questioning what they're claiming. And where's there room for that in science? I mean, isn't science supposed to welcome scrutiny? Isn't that how science progresses, is by scrutiny of peers reviewing claims and assertions made by other scientists? I mean, what are we doing here, guys? Anyway, so LiGo'd team have been so churlish in response, says Peter Coles, a cosmologist at Maynooth University in Ireland. Oh, I should have done his quote in Irish. Not everyone agrees the Danish choices are wrong. I think their paper is a good one, and it's a shame that some of the LiGo'd team have been so churlish in response, says Peter Coles, a cosmologist at Maynooth University in Ireland. McConaughey concurs. Right now, this is not the Danish group's responsibility. The ball is in LiGo'd's court, he says. There are questions that should be answered. Brown thinks the Danish group's analysis is wrong, but worth engaging with, and Cornish admits the scrutiny may not be a bad thing. He and his colleagues plan to put out a paper describing the detailed properties of the LiGo'd noise. It's the kind of paper we really didn't want to write because it's boring and we've got more exciting things to do, like finding snipes and measuring the dreams of farts and that sort of thing. But he adds, I added that bit in, by the way, that was not actually part of his quote, but he adds, it is important and increased scrutiny and criticism may be, in the end, no bad thing. You do have to understand your noise, he says. Wow, well, at least this guy has somewhat of a brain on his head. I mean, wow, that's a surprise to me. Cole himself doesn't doubt that we have detected gravitational waves, but agrees with Jackson that this cannot be confirmed until independent scientists can check the raw data and the analysis tools. Quote, in the spirit of open science, I think LiGo'd should release everything needed to reproduce their results. I'll do it in Irish. Coles. In the spirit of open science, I think that LiGo'd should release everything needed to reproduce their results. End quote. Jackson is unconvinced that explanatory papers will ever materialize. The collaboration has promised them before, he says. This LiGo'd episode continues to be, quote, this LiGo'd episode continues to be the most shocking professional experience of my 55 years as a physicist, he says. Not everyone would agree, but for a discovery of this magnitude, trust is everything. And again, I would mention here to Jackson, I'm sure he's not listening to this, but if he ever does hear this, the reason that they are so balls to the wall with these cockamamie, willy-nilly claims without backing it up, and really, I'm just going to come out and say it, lying, fudging their data, is because they did this in response to flat earthers just beating the crap out of the globe Earth model and beating the crap out of the theory of gravity in general. And when it became really public knowledge to the average person out there that the theory of gravity had never been proven, LiGo'd sort of had to come up with something. I'm not sure who calls the shots at the upper echelons, but it seems to me that it came from the very top of Alliance that, okay, LiGo'd, do your stuff, guys. You have to prove gravity waves. We don't care how you do it. We don't care, how you get the snipes. Just bring 12 snipes in. Nobody bothered to ask, well, what exactly are snipes? But at least the Irish guys were like, well, you don't even know what a bloody snipe is, for Christ's sake. Embarrassing noises. In 2014, the operators at the BICEP-2 telescope made an announcement so momentous there was talk of a Nobel Prize. A year later, however, far from making their way to Stockholm for the award ceremony, they were forced to admit they had been fooled by an embarrassing noise. And again, this was a year prior to LiGo'd's little press conference here. And of course, these were all coinciding. I think one coincided with Einstein's birthday, and the other was 100 years after the postulation of his general theory of relativity. I don't know, but they just had to have it right on time for Einstein to be perpetually correct. By the way, this will be a good time to plug a video I did a while back. It's a pretty good one. I think you'll enjoy it. It's called Einstein's Perpetual Pedestal of Correctness. Very enlightening. Okay, so anyway. Embarrassing noises. Situated at the South Pole, BICEP-2 had been scanning the cosmic microwave background, the pattern of radiation left on the sky from light emitted soon after the Big Bang theory. The big announcement was that it had found that gravitational waves had affected the pattern in such a way that proved a core theory of cosmology. The theory in question was inflation, which says the universe went through a period of superfast growth right after the Big Bang. For almost 4 decades it had been unproven. Now, suddenly, inflation supporters were vindicated. Okay. Just a quick point of contention here, and maybe this is too far off into the weeds, but they're talking about seeing light or radiation, a pattern of radiation, and again, this is the cosmic microwave background, pattern of radiation left on the sky from light emitted soon after the Big Bang. The Big Bang is a theory, they say happened billions, trillions of years ago, or whatever. But I'm sorry to say, you guys, the Big Bang Theory is only necessary, hypothetically, if the Earth is a spinning globe in outer space. Since the Earth is not a spinning globe in outer space and is demonstrably a stationary plane, there is no need for the Big Bang Theory, so the cosmic background radiation is something else entirely, making this entire venture that they described here in this subsection null and void, moot, just nonsense. Okay, anyway, except awkward warnings emerged within weeks, suggesting that cosmic dust clouds had scattered the radiation in a way that fooled the BICEP-2 researchers. In the end, the team's estimate of the amount of dust present and the analysis of the kind of noise the dust would produce both proved to be flawed. Noise can hoodwink even the smartest. That is why, despite LiGo'd being a highly respected collaboration, there is good reason to take questions about its noise analysis seriously. See the main story. Okay, so here we go with how to catch a wave. Output from gravitational wave detectors is full of noise. Disentangling the signal requires decision-making, and poor ones could be disastrously misleading. So there's guesswork involved, there's eyeballing involved, and, we're still going to catch these snipes though, right guys? Gonna get them. All dozen of them. The best weapon in the arsenal is known as a Fourier transform. This splits a signal into various frequency components and converts it into a power spectrum, which details how much of the signal's power is contained in each of these components. It can be done with a window function, a mathematical tool that operates on a selected part of the data. Whether or not to use one is at the heart of the disagreement over LiGo'd's results. See the main story. Andrew Jackson's dissenting team at the Niels Bohr Institute in Denmark chose not to use a window function, a decision that LiGo'd's Neil Cornish describes as a basic mistake. Jackson says they didn't use one because it subtly alters the Fourier transformed data in a way that can skew the results of subsequent processing. Makes a lot of sense. Even with the Fourier analysis done, judgments must be made about the noise in the detectors. Is it, for example, distributed in a predictable pattern equivalent to the bell-shaped Gaussian distribution? And does it vary over time, or is it stationary? The appropriate techniques for processing the data are different depending on the answers to those questions, so reliably detecting gravitational waves depends on making the right assumptions. Jackson's group says the decisions made during LIGO analysis are opaque at best and probably wrong. What a terrific article, just really well done. And honestly, I've never read much from newscientist.com, but this guy, Michael Brooks, did an excellent job of writing the article. And I must commend the guy, Andrew Jackson. You know, maybe it's something in the name, but it seems like this guy is, at least, you know, his moral compass is headed in the right direction, and he does have truth as the ultimate goal of his scientific endeavors, as opposed to others. Not going to say any names, but LIGO and NASA, where basically the funding is the most important thing to them, and perpetuating the status quo paradigm is just the most important thing ever, right? I mean, that's what they must do. So that's the end of that article, and I had one or two more that I wanted to breeze through with you guys. Or did I just close the wrong one? Whoopsie. Oh, wow. I think I might have just closed the wrong one. Let's go to the history here. Yes, this is the one I was looking for. Okay. So the next article we're going to look at here is from spaceplace.nasa.gov. So coming straight from the horse's mouth, the be-all, end-all source of truth, NASA. I'm kidding. I think I'm probably going to hell for saying that, so please do not take me seriously when I said that. Okay, so what is a gravitational wave? So we did talk a lot about gravitational waves and all that, and I just wanted to give a bit of a rundown. Maybe I should have read this article first, but hey, when in Rome, right? When we're trying to find snipes, we might as well start at the end and work our way back to the beginning, right? So what is a gravitational wave? The short answer, a gravitational wave is an invisible, yet incredibly fast ripple in space. So the very first sentence here on NASA.gov here, you guys, a gravitational wave is theoretical. One has never been detected, measured, proven, and yet we know it's incredibly fast. That's one thing we know about something that doesn't exist. Things that don't exist are very fast, right? Okay, anyway, gravitational waves travel at the speed of light, they say, 186,000 miles per second. These waves squeeze and stretch anything in their path as they pass by, says Nasser. They squeeze and they stretch. Yeah, sure they do. A gravitational wave is an invisible yet incredibly fast ripple in space. We've known about gravitational waves for a long time. More than 100 years, a great scientist named Albert Einstein came up with many ideas about gravity and space. Wow. So we've known about gravitational waves for a long time because Albert Einstein thunk it, right? I mean, this is how science is done, right, guys? Isn't it? I mean, Albert Einstein thunk it, so therefore it must be true. I mean, that's just so typical. Again, I'm going to point you in the direction of a video I did a while back. Please do watch it if you haven't seen it. Again, it's called Einstein's Perpetual Pedestal of Correctness. Brilliant video. And it may actually have another Einstein video that I'll point you to as well. I'll put some cards in corresponding places, links in the description, and on the end screen I will try to remember to place options for you to watch these Einstein videos I keep mentioning. It is important stuff, okay? I mean, not Einstein, but just what a buffoon and just a, I would say a fraud that he was, but anyway. By the way, Albert Einstein, officially 1921, won the Nobel Prize in Physics photograph. Wow. Okay. So, Einstein predicted that something special happens when two bodies, such as planets or stars, I thought it was going to say males and females, but no, planets and stars, not that juicy. When two bodies, planets and stars, orbit each other. He believed that this kind of movement could cause ripples in space. These ripples would spread out like the ripples in a pond when a stone is tossed in. Scientists call these ripples of space gravitational waves. So let me just stop the wagon here real quick. Back up the wagon, you guys, because he's talking about, throwing a rock into a pond and you get ripples. We can all understand that. That makes a lot of sense. But in space, we are talking about null, void, nothing, nada, zero space. It is a lack of stuff. It is a vacuum. Okay, sure, you allegedly have stars and planets and moons and meteoroids and asteroids all throughout space, but at the end of the day, what we're talking about here is the negative space, the expanse that they claim goes on practically for infinity. So you tell me, you guys, if you throw a rock into a pond of water, it makes ripples. But if you throw a rock into a pond lacking water, a pond with nothing in it, where's the ripples? I mean, what kind of ripples are we going to make then? Huh? Well, I'll just let you be the judge on that, and I'll give you my opinion. Well, you're not going to have many ripples at all because you don't have any sort of media to house the waves. Right. Sorry, I just love doing accents sometimes when we do these sorts of videos, so forgive me. Okay, so gravitational waves are invisible, it says. However, they are incredibly fast. I think that's the third time this article has mentioned that. I'll tell you, NASA.gov, you should let me write your articles, dude. Really, is that the third time that they've said literally gravitational waves are invisible but incredibly fast? Let's see here. Okay, it says it here at the top. Gravitational wave is invisible yet incredibly fast. It says it here, gravitational wave is invisible yet incredibly fast. Okay, and then it says it down here. Gravitational waves are invisible, however, they're incredibly fast. Really, is this the best sort of articles we get from NASA.gov? With their billions and billions of dollars. Please, you guys, NASA, give me a job writing articles, or at least cleaning up your mess on your articles. I promise. I won't debunk any of your stuff if you give me creative liberties in your website. Well, I can't make any promises, but at least I can promise that the truth will be on your website. Anyways, it says here that these hypothetical, fictional, non-existing gravitational waves, which did I mention that they are invisible but incredibly fast? They travel at the speed of light, 186,000 miles per second. Gravitational waves squeeze and stretch anything in their path as they pass by. Well, where have we heard that before? What causes gravitational waves? Well, the most powerful gravitational waves, by the way, so they're telling us what causes gravitational waves. They're telling us about different types of gravitational waves. You got some less powerful, some most powerful, and yet to date, there is no evidence for gravitational waves ever to this very day. But the most powerful gravitational waves are created when objects move at very high speeds. Some examples of events that could cause a gravitational wave are when a star explodes asymmetrically, called a supernova, when two big stars orbit each other, when two black holes orbit each other and merge. Okay, so just a bunch of theoretical nonsense as far as I'm concerned. I would play this little thing here, but who wants a copyright strike, right? But you can see ripples in space. Yeah, as if, right? Let me go get my jet ski, and I'm going to put it in the air. And I'm going to gun the engine and just see how fast my jet ski goes, right? In the air, right? Go very fast, I'm sure. Anyway. But these types of objects that create gravitational waves are far away. And sometimes, these events only cause small, weak gravitational waves. The waves are then very weak by the time they reach the Earth. This makes gravitational waves hard to detect. Because I gotta tell you, it's hard to be NASA. Oh yeah, hard to be NASA. And, I gotta tell you, I will mention here, according to the Alliance standard model, right? We have the Earth orbiting the Sun, the Moon orbiting the Earth. We are held to the Earth by gravity, and all of this is governed by gravity. I mean, shouldn't gravitational waves just be abound? Shouldn't they be everywhere? Shouldn't they be detectable just all over the damn place? I mean, electromagnetic waves are detectable on any scale, small scale, micro scale, macro scale. Electromagnetic waves and effects are demonstrable, detectable. I wouldn't maybe say tangible, but it's something that we know exists, and there's no doubt about it. Now, the inner workings of exactly what's going on in sort of electrical systems or electromagnetic systems, that's a horse of a different color. But we do know that it is a thing, right? It's definitely a phenomenon. Gravity, not so much. So they say that this makes gravitational waves hard to detect, the fact that it's weak and far away objects. But I would say what makes gravitational waves even harder to detect is that the damn things don't exist. And here we go. How do we know that gravitational waves exist? In 2015, scientists detected gravitational waves for the very first time. They used a very sensitive instrument called LiGo'd, Laser Interferometer Gravitational Wave Observatory. These first gravitational waves happened when two black holes crashed into one another. The collision happened 1.3 billion years ago, but the ripples didn't make it to Earth until 2015. Now, I know we've just discussed all of this, so NASA.gov leaves up on their webpage, and again, the date today is, we're at July 30th, July 31st of 2021. This is 6 years old. It was debunked by mainstream science, peer-reviewed guys, not flat earthers, but debunked by their own guys, some of the boys, years ago, and yet NASA still has this stuff posted up as being proven, so that, well, this is why, I'll tell you why. When flat earthers make the bold claim that gravity is a theory that's never been proven, well, the globetards can go to web pages like this here. See, it says NASA.gov, and here it says right here, we do have proof of gravity waves. That's why. And, who cares if this stuff is, you could say it's being debated by scientists, but no, it's been debunked. I mean, even mainstream scientists that don't have their heads up their buttholes say that it's basically a bunch of malarkey, right? Like Andrew Jackson, okay? And I'm just out of curiosity, I do want to see, when was this article published? Does it say? Who cares anyway? But the point is, they still have it up. It's not like they took it down. You'd think that NASA would take this sort of thing down, right? And here's a nice picture of LiGo, the multi-billion-dollar lie factory, NASA's El Cheapo cousin, right? And here we go, back to Einstein's perpetual pedestal of correctness. Einstein was right, of course he was, because Einstein can never be wrong, because he's Einstein, and whatever he thunk is true, no matter what, and we will spend the rest of our lives trying to prove him right, proving him right, even if his claims are just malarkey, hogwash, couldn't possibly be true. For some reason, he just is forever correct. I mean, he gets a free pass when it comes to science, or liance, or pseudoscience, because, well, with a name like Einstein, how could you be wrong, right? I mean, that's pretty damn good science. His name's Einstein, so hey, and he invented a bra. Yeah, look it up. See my other videos I've mentioned. Okay, so the first detection of gravitational waves was a very important event in science. Before this, just about everything we knew about the universe came from studying waves of light. Now, we have a new way to learn about the universe, by studying waves of gravity. Or, wait a minute, does it say by studying waves of naivete? That's what it is, by studying waves of naivete. Great. Gravitational waves will help us to learn many new things about our universe. We also may learn more about the galaxy, about gravity itself. Really? So by studying gravitational waves, we might learn more about gravity. Well, that is just profound writing. We ought to give this, who are these guys? NASA? We ought to just dump billions of dollars at these guys, because I'll tell you what, their websites, their articles are just profound, man. Profound science right here, you guys. And how are gravitational waves detected? And it goes on to tell you about LIGO. We know all about that. We've been through it ad nauseum in this video. So, yeah, catch a wave. Looks like we've got that done. LIGO, what are gravitational waves? Yeah, so, and this is the final article I was going to read. It may not be necessary, but I think that it is, just for a bit of background. And again, this is caltech.edu. So again, mainstream. These are not flat Earth sources that I'm citing here. These are mainstream. LiGo.caltech.edu. Okay. What are gravitational waves? Gravitational waves are ripples in space-time caused by some of the most violent and energetic processes in the universe. Albert Einstein, you guys ever heard of him? Albert Einstein. He predicted the existence of gravitational waves in 1916, so they must be true. No, in 1916, in his general theory of relativity, Einstein's mathematics showed that massive accelerating objects such as neutron stars or black holes orbiting each other would disrupt space-time, a theory, in such a way that waves of undulating space-time would propagate in all directions away from the source. These cosmic ripples would travel at the speed of light, carrying with them information about their origins, as well as clues about the nature of gravity itself. Wow, I wonder what kind of clues. Clues like gravity doesn't exist, couldn't possibly exist, has no theoretical need to exist, because the Earth is not a spinning ball. This all comes back to curvature, you guys. This all comes back to lack of geological motion. If there is no geological motion, no axial rotation, no orbital motion of every sort, if there is no curvature to the Earth sufficient to result in an overall sphere, then the Earth cannot be a spinning ball. And therefore, all of the theories of Big Bang and gravity universe are just completely useless. There is no potential need for them. Okay? The strongest gravitational waves are produced by cataclysmic events such as colliding black holes, supernova, massive stars exploding at the end of their lifetimes, and colliding neutron stars. Other waves are predicted to be caused by the rotation of neutron stars that are not perfect spheres, and possibly even the remnants of gravitational radiation created by the Big Bang. The animation below illustrates how gravitational waves are emitted by two neutron stars as they orbit each other and then coalesce. And I think we've read quite enough of this, you guys. This is just more pro-NASA crap. But it goes to show you that here, 6 years later after LIGO allegedly came out with their so-called proof of gravitational waves, that is really under question, and I would say even rejected by mainstream scientists who have any sort of moral compass and wherewithal. And yet, LIGO, NASA, they still leave this stuff up as if it's fact, and that to me is just absurd. I am curious what the LIGO Caltech for Scientists button says here. I really am curious to see. This page contains information and resources for professional researchers interested in LIGO science. Click on a topic below to learn more. Use LIGO data, LIGO's impact on science, that may be interesting. LIGO research and development, detection papers, collaborate, all publications published, scientific articles from LIGO researchers, observatory status, the LIGO Laboratory Award for Excellence in Detector Characterization and Calibration. So, you got to give each other awards, right? Because that's the most important thing in science is accolades. I mean, who gives a damn about the truth? But a nice bozo button sometimes, really, that's what it's all about, guys, of course. Okay, so I do want to read about LIGO's impact on science. LIGO's impact on science and tech. None. N. No, I'm kidding. Okay, so this is what they say here on LiGo.caltech.edu. Gravitational wave detectors like LiGo will answer some outstanding questions related to gravitation and astrophysics, such as: is general relativity the correct theory of gravity? How does matter behave under extreme densities and pressures? How abundant are stellar mass black holes? What is the central engine driving gamma-ray bursts? What happens when a massive star collapses? Now, frankly, you guys, I'm really not too sure. Now, I am no scientist, of course, but I'm not too sure how these laser interferometer devices on Earth are going to tell us diddly squat about what's going on inside of black holes and inside of gamma-ray bursts and inside of massive star collapses. Really, I mean, we're talking about laser beams firing here on the ground in reality down long tubes and back at each other. I mean, dude, what are they talking about, man? I mean, sure, I'm positive there is some long drawn out PhD thesis that can tell me just how stupid I am because I don't understand how any of this stuff could apply to space. But again, what do I know, because I'm sitting here telling you that space doesn't even exist, as we've been taught. There is no such thing as space. So, okay, yes, there's space, like, you know, I'm like, here I am, and then over there's my kitchen, and in between me and my kitchen, there is some space. And I'm talking about infinite space, the infinite space universe theory that doesn't exist. It is a fantasy that has been instilled into our minds since we were little kids, starting, you know, with the globe in the classroom, and continued and enforced by movie franchises like Star Wars and Star Trek, TV shows like Lost in Space, and on and on and on. And let's not forget the UFO and alien agenda. And again, I am a big proponent for UFOs and extraterrestrials. I believe they are definitely a possibility. But when I say extraterrestrial, I do not mean that they are coming from some other planet in space. They are coming from some other geothermal pocket right here on the ground in reality that is beyond the confines of the little area that we call Earth. And I would say go ahead and check out a video I did a couple of years ago. I'll put a card here if I can remember to, called Beyond Flat Earth. Check that out. It gets into that very topic indeed. Very fascinating stuff. So just read this a bit, or maybe I will. Okay, so yeah, we will read into this. So the little the section here for scientists says LIGO will also directly engage the scientific community in multi-messenger astronomy, a collaborative effort where gravitational wave detectors and various kinds of telescopes observing with electromagnetic radiation such as visible light, X-rays, gamma rays, radio waves, etc., and even neutrino detectors observe astronomical sources at the same time. Each method of observing provides a different look at the same objects or phenomenon, allowing them to be studied in multiple ways and revealing relationships and interactions never before observed. Last but not least, though its advances in technology and scientific methods, LIGO also contributes to other fields of science and to the broader technology enterprise. Well, do tell more. Let's see what else LIGO is into. How are they improving our everyday lives here on planet Earth? The direct attention of gravitational waves requires multiple detections from widely separated sites. To enhance detection capabilities, LIGO researchers are working closely with gravitational wave researchers at Virgo in Italy and Geo 600 in Germany, and they are assisting the Japanese as they build Kagra. In addition, for years, LIGO staff have been training Indian engineers to prepare for the construction of their third LIGO interferometer in India. Okay, so basically they are procreating life factories. So this is LIGO's contribution to science. They are bilking taxpayers all over the world to build more life factories. Well, ain't that just a hoot? I mean, why stop with the space programs? We've got 1 or 2 LIGO devices here costing us billions of dollars, accomplishing fuck all. We might as well put them up everywhere, right? Yeah, sure, we can afford it. It's not like we have all kinds of crises going on in this world involving, well, fiat currencies going belly up, the wealth divide being at an all-time schism high, at an all-time chasm. The chasm, the disparity in wealth, that chasm is at an all-time high. Yeah, sure, we might as well dump billions and billions of dollars into more life factories everywhere. Yeah, India, sure, they can afford it. A lot of those people in India, I mean, what, they eat like twigs and bugs for dinner, don't they? I mean, I don't know. I've never been to India. I just know what I've been brainwashed into believing here in America, you know, but hey, man, sure. Look at all the homeless people right here in the United States. I'm homeless, you know. I live in a hotel by the grace of God, and I'm very grateful for it. And it is only by the grace of God and with the help of a few friends that I'm able to even stay off the street on a nightly basis. But sure, billions of dollars into LIGO, very important stuff, you guys. Because we have to be out there hunting the dreams of farts and the snipes, right? Such important stuff. Less than 2 years after LIGO's first detection of gravitational waves, again, they're boasting on something that didn't even happen. They just made this crap up and then say that it happened, even though the actual scientists are like, what are you guys talking about? You eyeballed it, you're making it up, it's for teaching purposes, and yet you're calling it fact? If this isn't science, yeah, dump billions of more dollars at these guys, sure, why not? This momentous next step was taken in August of 2017. LIGO detected a gravitational wave from what immediately seemed too many to be a source never before seen in its detectors. Combining their data, LIGO and Virgo quickly localized the region of the sky from which the signal emerged. They're still on with this shtick years and years on later, when it was just background noise, you guys. I mean, these people are just bold-faced lying. I mean, this needs to be taken down. I mean, when did they edit this crap out of their records? I mean, this goes into the scientific record as fact. People cite it. You know, this is what people go on believing is fact. And the truth of the matter is, you guys, there's no such thing as gravity. It's never been detected or demonstrated or anything. So I think that about wraps it up. Real quick, I do want to give a couple of shout-outs. Dr. Eminem, you know who you are. Marcello, my buddy in Italy. God bless you, my man. Daryl, California grower. The dank is strong with you, my friend. Love you, buddy. Adnan, you're the man, bro. Love you. Hope things continue to improve for you. And there's a handful of you guys out there. I'm not going to try to mention everybody that has been a lifesaver and helped me to really survive this crazy, crazy world that's been going on for the last couple of years. But as I wrap this up, I just want to really just thank you for listening. Thank you for sticking in. Thank you for being open-minded. God bless you guys. I love each and every one of you. I am concerned for the future, not just the future of the world. I mean, who ain't? My personal future is, as always, very, very uncertain. You know, I don't know where I'm going to be from day to day, but I damn sure am going to try to be at Flaptoberfest 2021. Karen B, lover. Karen B was actually the first flat earther I've ever met in person. She gave me a ride to the first flat earth party I ever went to. I was up there in North Cac. South Cac? I don't remember. I was in South Cac. Karen B picked me up from North Cac, and we drove to I Spy NASA Lie's house, and we had a party with Zulu One and a couple other people, and it was just a small gathering. But yeah, Karen B was my first flat Earth friend, and love her to death, the OnStar girl. And so I am going to make every effort to make it out there to Flattoberfest 2021. I do have transportation. Thanks so much to Richard and Priscilla. You guys are angels. Love you guys. And just, you know, as always, you guys, if you would like to help this channel continue, I need your help. I mean, what more can I say? I give everything out for free. The information I give out here is given to you freely. Ads are usually skippable if there are any ads. And if you'd like to contribute to this channel effort and help me continue surviving and continue creating content, you can do so through PayPal or Patreon, Cash App, and there's a few options, whatever's easy for you. And you know, if you can't help and you want to, hey man, it's the thought that counts. God bless you for that too. Maybe one day I will hit the lottery and send every flat earther that's ever sent me an email, send you $1,000. I don't know. Honestly, man, I would love to help people if I could monetarily, but instead what I do is I try to help people with the truth. And it is, you know, there are personal sacrifices that come with disseminating this truth, and it's not always pretty. We're not always perfect, never perfect, but we strive to at least be true to ourselves, true to you, the viewer, and true to the Most High, God, the creator of all things. With Him, everything is possible. My faith is strong because it does appear that we are living through revelation. Come on, you can't deny it. We're living through revelation, and with that comes tribulation. Okay? And so if I can go through tribulation so that one or two of y'all doesn't have to, maybe you guys can have some revelation without the tribulations, I will bear that for you guys. Okay? Honestly, what I've been through the last couple of years, y'all, I wouldn't wish on my worst enemy in terms of the tribulations. As far as the revelations, it is such a blessing. I mean, honestly, I don't think I could see myself back in the Matrix, in the globe-tard paradigm ever again. I'm so glad I'm out of that. I would sacrifice every material possession I've ever had and ever will have for the truth. And frankly, I see it as a miracle of the Most High and His angels of revelation that we are even having these conversations, because the deception in this world is strong, but we are breaking through it. The tide of this thing has turned. There is many positive things on the horizon. And if I have to literally sacrifice my mind, body, and soul for the truth, I will do it, you know. So I can't guarantee you for how long I will be continuing to put out content. I will do it as much as I can. But, you know, it's just, the end of the rope is near. And I've got some really great people that give me emotional support and encouragement. It means a lot to me. There's a handful, a very few of you guys out there, and you know who you are, that give me financial support and encouragement. Without you guys, none of this would be possible for me. And I'm just one guy, man. I'm nothing special, but I do promise you this. I promise you that I will always be true to you, true to myself, striving to break the chains of deception and ignorance in this world. And all praises go to the Most High, the Creator of all things visible and invisible. I pray that each and every one of you guys out there and your families is moved and touched by the angels of revelation, who are very real, very strong, very powerful. All you have to do is let them in. Knock, and you shall be given entry. Ask, and you shall receive. These promises made by Yeshua, the Master, the Teacher, are always kept. So that I can attest to. The angels of revelation I can attest to. I can't prove that they're there, but I can tell you that they are. I mean, I can tell you through personal experience, they are very real. Just as real as you and me. They may exist on a slightly different vibrational state. And they may not always be on this physical plane. Sometimes they are. Sometimes they might be walking right past you and you wouldn't even know it. So be kind to one another, you guys. Because for all you know, there may be an angel of the Most High right there next to you. And if you are rude to them or snub your nose to them, that sort of thing is not cool, man. Because they offer many blessings that you could never foresee. I mean, things like, I don't know, there's things you can never foresee. Like, let's say you take a wrong turn on your way to work and maybe you get a little upset about it. But then you get back on track to work and maybe you're a little bit late. Who's to say if you didn't take that wrong turn, you wouldn't have got creamed by a semi-truck, right? And it is those very angels, your guardian angels, or maybe the angels of revelation in some cases, that are there watching out for you. And I'm here to tell you, you guys, you walk the path of truth and righteousness and really give it the old college effort. And blessings will come to you. That I can promise you. So I'm very tired as I record this. I'm going to go ahead and wrap this up, you guys. But I do love each and every one of you. Feel free to get in touch with me by email or phone. Most of you guys have my number, but give me a call. Text me first, 864-315-7892. Please feel free to contribute whatever you feel the content is worth. There will be more content on the way. And I will see you soon in the next video. With that, spread the word, spread the world, and peace out, everybody. God bless.